开始。
Hello. So this is a makeup class. So we'll talk about mesh analysis. Last week we mostly talked about nodal analysis. So this week we'll talk about mesh, which is another way of doing analysis. So this is an example. So mesh analysis, you'll see has its own merit. So sometimes you want to use nodal analysis. Sometimes you want to use mesh. So it's also a powerful tool. So let's starting to see how the mesh analysis works. Okay, basically nodal analysis starting with identifying number of nodes, but mesh is starting by analyzing the number of current mesh. Okay, so what is exactly is a mesh? Mesh is it's basically a loop. Okay, so you can think of from this way, this is a mesh, and this way is another mesh. Okay, so from this figure you see there are two mesh. So your unknown or the variable you want to try to solve is basically the mesh current. And so once you solve the mesh current, then you know the current through each device and the voltage, etc., etc. Not just like what we did in the nodal analysis. In nodal analysis, the unknown is the node at each node. So you try to solve those first, then you use those information to solve individual current, etc. Now in mesh analysis, the unknown is the current in each mesh. So so you have a general feeling about mesh analysis now. So let's use this as an example to see how this works. Okay. So first you arbitrarily pick the direction for your mesh. So for mesh number 1, let's say we have I1 of this way. And for mesh number 2, we have I2 of this way. So I1 and I2 are the unknowns we try to solve. Now, so then we need to find the equations, right? We have two unknowns. Then we need two equations for the two independent equations to solve the two unknowns. So fortunately, there are two loops we can apply KVL. So then we can use the two KVL equations to solve these two equations. Now, so before we starting to solve KVL, we need to find out the current through each device. Okay. And the current through each device can be different. It's not exactly. Sometimes it's not exactly the mesh current. So let's take a look. Okay. So the current. So now let's see. We want to find a KVL equation for this one. So for this loop, so we have we raise up by 40, right? We raise up by 40. Then we find that R drop of the 3 ohm. Let's say this is R1, and this is R2. This is R3, R4, R5. Okay, so then so 40 ohm will equal to the, let's say we label this is our direction. As I said, you have to pick the direction. So to be consistent, let's make the direction consistent with our loop direction. So this is plus, this is minus, and so this will be plus, this will be minus. Okay. So if you do the loop in this way, so the 40 will equal to the R drop of R1, right? Will be VR1 plus voltage drop of R4 plus VR4 and plus voltage drop of this guy of R2 plus VR2. Now for VR1, this is the first equation for KVL for first loop. KVL for mesh 1. So then we need to solve. We need to figure out how to correlate VR1 with your mesh current I1 and I2. So if we have two mesh current like this, so the current flowing through R1. So basically IR1, because this flows in that circle, right, and has nothing to do with the current inside R1. So the current flowing through R1 will be exactly I1. So VR1, according to Ohm's law, will be IR1 times R1, will be I1 times R1. Basically will be, let's say if it's 3 ohm, will be 3 I1. Okay? Now let's find the current through R4. So it's slightly different. Okay, you have loop current of mesh 1 going down, and you have mesh current of this current going up. So your current will be mesh current 1 minus your mesh current 2. Okay, because they're going different direction, and your R4 current is assuming the same direction of mesh 1. So it's I1 minus I2. So VR4 will be IR4 times R4, basically Ohm's law. So it will be 45 ohm times I1 minus I2. Okay? Now number 3 is VR2. So we found out what's current of IR2. IR2 again, this one is nothing to do with the current inside that loop. So IR2 is simply I1. So again, VR2 will be IR2 times R2. So that's 2 ohm of I1. So we have this. Then we take all this information back to here. So we have another equation. So which is 40 equal to 3I1 plus 45 I1 minus I2 plus 2I1. So another rearrange it will be 50 I1 minus 45 I2. Okay, so that's equation number 1. So double check, make sure the direction is right. So I1 is going this way, and we're assuming voltage drop of plus minus, plus minus, plus minus. So VR1 will be 3I1, and this will be 2I1, and this will be 45 I1 minus I2. So that's why 45 plus 2 plus 3 is 50 minus 45. Okay, that's exactly what we have. Now let's repeat the same thing. So I'll erase this part. Let's repeat this thing for so this one KVL for mesh 2 will get this equation. Now let's solve for this one. Okay, we're assuming a KVL direction of this way. So KVL direction of this way. So that means 64 equal to VR5. So this is raised and this is down, and okay, this also needs to be done. So that's minus, because we already defined the direction of this is plus, this is minus. So this is raised, so it's minus. So minus VR4, and then this way, you saw plus here, minus here. So that's plus VR3. Okay, be careful about VR4. It's a minus sign because we already assigned this is plus terminal, this is minus terminal. So when you go look this way, you saw a voltage raise. So ideally, voltage raise should be on the left side, like the 64. So that's why you saw the minus sign here. So So let's try to solve VR5 first. So VR5, because let's see the current of all we know is IR5 times R5, right? So IR5 is this way. So that's I2 times R5, okay? Which is 1.5 I2. Now VR4. We already assigned, we already calculated previously, so that's IR4 times R4, which is 45 times I1 minus I2, okay? Okay, so don't mess up the signs and, okay, be careful. And then VR3 will be IR3 times R3, which is, okay, which is I2 times 4 ohm. Okay, so I assume this is plus side, this is minus side. Okay, and my mesh current is that way, and my resistor current is that way. So it's the same. So again, I get equation of 64 equal to 1.5 I2 minus 45 I1 minus I2 plus 4 I2. So simplify, I get 64 equal to, so this is minus 45 I1. 45 plus 4, 49, 50.5 I2. Okay? So that's the second equation. Okay? So from these two equations, then you can solve I1 and I2. Okay? So what do you do? So what do you do? Is you multiply 1 by 50 plus 2 multiplied by, so we try to get out of I1. Sorry, first one multiplied by 45 plus second one multiplied by 50. Okay, you then get cancel the I1 exactly. So that will be 2000 of 50 times 45 I1 minus 45 squared I2. This will be 64 times 50 equal to 50.5 times 50 I2 minus 45 times 50 I1. So if you sum them together, get cancelled. So I2 will be 55 times 50 minus 45 squared, and this is 2000 plus 64 times 50. So so that will be 2000 plus 3200 over 25 minus 45 squared. Minus 2025. So that will be 500 of 5200. So that will be 500 10.4. Okay, so okay, if I2 is 10.4, then I1 will be 50 of 40 plus 45 times I2, right? According to equation number 1. So that will be 0.8 plus 0.9 times I2. So that will be .116. Okay? Okay? So that's how we solve for this equation. Okay. So so again, as we have experienced in nodal analysis, there will be some limitation on how you can use it. Remember, in nodal analysis, when you have something, when you have two nodes and connected by a voltage source, then that one is hard to find a independent equation to correlate the current of this branch with the voltage, because for a voltage source it can be anything. The current, there's no Ohm's law to correlate the voltage through of the voltage source and the current through it. So there is no independent equation. So the only independent equation is this node, and this node is different by this voltage source. So again, we have this similar situation in mesh analysis as well. So the only difference is if we replace the voltage source with the current source. So for something like this, okay. Again, we have if we continue what we have, we have a mesh current IA, and we have another current IB. Okay. So what I have done is we assuming IA and IB are the mesh current. So then we try to solve. We have two loops. We try to use KVL for these two loops. Now, as you know, nodal analysis is based on KCL. It's trying to solve the current inside. So if there are n nodes, there are n KCL equations. So, but for mesh is based on KVL. If there are n mesh, then there are n independent equations. So, but right now, the issue is, okay, we can try to write a KVL for this loop, but the problem is we cannot find an independent equation that describes the current of this current source and the voltage across it. This voltage can be anything. So, how So the issue is now, how do we solve a situation like this? Okay, so the situation like this is, okay, when you have this one in the loop, then you cannot write a KVL equation, but you can write a KVL equation for a big one. So you cannot write a KVL for, there's no meaning to write a KVL for this loop. Also, there's no meaning to write a KVL of this loop because you don't know the voltage of this one, even if you know the current. So, but you can write a KVL for the whole loop, and you can write a current equation between these two. So that's how you are going to solve this equation. Okay, let's start by doing this. Okay, so if you still have these two loops, use IA and IB as a variable. Now the issue is, how do we write the KVL for the bigger loop? So again, this one has nothing to do with the current in that loop. So if we label this plus minus, and since to make things easier, let's follow the direction of loop current. So this will be plus, this will be minus. So this will be plus, this will be minus. Okay, this is R1, R2, R3, R4. So the voltage drop across R1 will be, as we said, IR1 is simply IA. Okay. So for IR2, again, there's no current, there's no relation of this current to this resistor. So IR2 will simply be IB. Now, again, IR3 is very simple as well. So IR3 will be IA, and again, this one, IR4 equal to IB. Okay. So let's write for the whole loop. So it's a raise up. So 18 volt will be equal to drop. So that's 3 IR1, and then another drop plus 9 IR2. Okay, another raise, so it's a minus 15, and then a drop of R4 plus 6 R4 IR4, and then another drop, so plus 2 times IR3. Okay. So let's take into here. So it'll be moved 15 here. So that will be 18 plus 15 equal to 3IA plus 9IB plus 6IB plus 2IA. So that will be 30. So if I write here, 33 equal to 5IA plus 15IB. Okay, that's first equation. First equation you have. Now we find a relation between IA and IB through this current. So what does that mean? If this current is flowing up, so IB, and this current also flowing up, but this current flowing down. So IB minus IA, same direction current, should be equal to 3 amp, right? Because IB going up, IA going down, and then you have a remaining of 3 going up. So IB minus IA is 3. So we arrange it so 3 will be minus IA plus IB. So